Almost 40,000 people are killed every year in the United States in car accidents. But the auto industry has impressive new technology coming that could slash that number. On this week's show, Jada Smith talks about the role Aptiv is playing in bringing this technology to market. Underwriting for the production of Autoline This Week has been provided by Borg Warner.
The world is changing at an ever-increasing pace. No matter what the mode of transportation, there is always the need for an efficient propulsion system. And that's exactly what Borg Warner has been doing since the earliest days of the automotive industry. We create innovative mobility technologies that reduce energy consumption and emissions while improving performance. Our proven track record has made us an industry leader in forward-looking propulsion solutions for combustion, hybrid, and electric vehicles.
And now, here's your host, John McElroy.
I want to thank you all for joining us on Autoline this week. You know, there are about 40,000 people killed in motor vehicle accidents in the U.S. every year. But the auto industry is working on some amazing technology that could really address that situation, both short-term technology and long-term. We're going to be talking about that today because our special guest is Jada Smith, who's the Vice President of Advanced Engineering at a brand new supplier company called Aptiv. We'll get into that a bit. But Jada, great having you on the show.
Thank you.
Also joining us today are Jack Keebler from Keebler Auto and Michelle Krebs from Cox Automotive. And great to have the both of you here on the show as well.
Thanks, John.
Let's start out explaining, because Aptiv may not be a household name in a lot of circles. What is it, Jada?
It may not. So back in December, we spun off our powertrain segment. We were formerly known as Delphi. The high-tech portion of the company that was left, focusing on advanced safety systems, focusing on connectivity, infotainment, interior and exterior sensing in the vehicle, and automated driving, that is Aptiv.
Very good, because I think a lot of people do know the Delphi name, but Aptiv is pretty new. Let's get into the safety technology. It's known by ADAS, Advanced Driver Assistance Systems. Mm-hmm. And what exactly is Aptiv working on with ADAS, and how do you see it coming?
Well, it's interesting. We, as Delphi, launched the first active safety system that used a radar and cruise control back in 1999 on the Jaguar. And now we're on our 8th generation of radar technology that's enabling the lowest level of automation, what we call a level 0 system, all the way up through a full level 5, a full autonomous system. So that means we're delivering features like lane departure warning, like automatic emergency braking, forward collision warning, blind spot detection. All of those features are enabled by our technology.
How widespread is this, and how widespread will it become in the next few years?
I think it's fair to say that it's gaining more and more traction. As more and more consumers experience the benefits of active safety technology, they buy in. And as they buy in, we're starting to see that technology become more affordable and more available to consumers. We talk about something called democratization of technology. What that means is when technology is first released, it's often only available to a premium type segment. So think flat screen TVs. When they first came out, they were insanely expensive, which means only the rich could afford them. Over time, those prices came down, and now it's affordable and it's available to everyone, and nearly everyone has one. The same is true with active safety technology. That first radar system that we delivered back in 1999, we had a joke that if you purchased a radar, you could get a Jag for free. It's because the technology was so expensive. Now, you're seeing that same technology, newer generations of it, on vehicles in the value segment. And that is the democratization of active safety at its best.
I would say, John, our studies show exactly that. We just finished a mobility study, and this has been true for quite some time. People say their next vehicle, they want all these different safety features on, and the numbers just keep going up. So you're absolutely right on.
Is there a particular slice of that people are maybe shopping that's become so ubiquitous that they're like, okay, I definitely need collision warning on the car, I definitely need,
It's interesting.
Have they picked something out there?
There are some features that consumers appear to like more than others. So one is blind spot detection.
That's what all the data shows.
They
Number one
love
on our
it.
list.
People love blind
They love
spot
it. They're not willing to live without it. And we're seeing that with other systems too. It's interesting, I'm sure you guys are all aware that 20 different automakers have agreed to put low-speed automatic emergency braking and forward collision warning on their models by 2022, making it standard. And that's incredibly impactful.
Jada, explain that technology a bit.
Or not so impactful.
Yeah.
Yes, exactly.
Explain what you mean by automated emergency braking and forward collision warning.
So forward collision warning, that's when the vehicle will detect that you are approaching another vehicle in front of you and a collision could be imminent. So it warns the driver. That's the driver's opportunity to take action. If the driver doesn't take action for whatever reason, then automatic emergency braking can kick in, and that is where the vehicle will stop on its own for you. And that type of technology, you're seeing it advertised more and more from the automakers, and it's becoming something that people are wanting to have. So not only have the 20 different automakers said that they're going to make that technology standard on their vehicles by 2022 here in the United States, but that technology has also been mandated by the EU, the European Union, on their heavy-duty commercial vehicles as well, those that weigh over 7,000 kilograms. So it's impactful, or not impactful. It's technology that people want and they recognize the benefit that it can have. It's interesting that IIHS predicts that by 2025, this technology, the combination of low-speed automatic emergency braking with forward collision warning, can avoid 28,000 different accidents and eliminate 12,000 injuries. That's the impact that just these two features can have on consumers.
Are all these systems equal in terms of their performance?
I guess, what do you mean by equal?
Because, you watch the commercials on television and they show the vehicle stopping. Some of them, do some of them stop more aggressively, like say decel at a higher rate than others? Or is there an SAE standard for that? Or
I'm not sure on the standard element of it, but there is some level of configuration that you can do depending on the type of vehicle. So it's not necessarily a one-size-fits-all approach. The technology itself can apply to all, but how it's implemented could vary depending on what the OEM needs.
So you're raising a good issue, because I want to say it was Consumer Reports that did a variety of tests.
Just recently.
Just recently, exactly right. And they found quite a bit of variation between automakers, some being terrific, others not that they're not terrific, but not up to
perhaps
snuff.
Perhaps not as aggressive.
Exactly.
Well, remember, we also saw that with anti-lock brakes and stability control systems. We saw a lot of variance in how aggressive they were or not aggressive.
Or how protective they were.
Right. Well, is it just up to your customers, the car companies, to determine how to calibrate all this, or are there any standards, or what do you, as Aptiv, bring to the party?
We obviously bring a lot of know-how, right? So as we go and we're implementing this, we take a holistic view to the system. So you can't look at each of these features in isolation. You have to look at it with the vehicle as a whole, and that starts at the electrical architecture and goes all the way through every sensor up to the cloud, and taking that holistic view and then going back to the automaker and saying, we have all this experience, all this capability, let's work together to come up with a solution that works best. The other thing to keep in mind is each of these features, it's almost like a tool in a toolbox. They're all designed to do a job. They have a purpose. So it's important that when we think about the purpose of each of these features, that we combine them in a way that's going to maximize their capability in the specific environment in which they're operating. There's differences if you're in an urban environment versus more of a highway environment. There's differences in a US highway versus a European highway. So as you go in and take all these features and combine them together, it's important to keep that in mind, that we have to make sure that everything we're doing works for the situation that that vehicle is going to be in and the people inside that vehicle are going to be in.
What's the next step after that in terms of technologies? Maybe even that people don't have on their must-have list yet.
Well, the next big things are building upon those active safety features. So we talk a lot, you hear a lot of buzz around automated driving and autonomous driving. And we like to say that the foundation for that is active safety. It's taking the sensors, it's taking the know-how of combining the data from those sensors to make smart decisions, and it's taking it to the next level when you get to these level 4 and level 5 autonomous systems. But the importance is not stopping there. You have to take everything you learn and feed it back into those active safety systems so that they can get better and better and better. But it's also around connectivity. So people want active safety, we know that. But at the same time, they want all the connectivity that they're used to in their home. So how can we take the sensors that we have and create a more connected experience for them, both inside and outside the car, that still gets them to where they have to go in as safe way as possible? And that's what we do.
Could you give us like a scenario of how, I try to explain connected and how that will look in the future. Can you give us some examples?
Well, it's interesting. We put a lot of thought into how does connectivity, what does it look like today, and what does it look like in the future when perhaps you're in a ride-hailing, a robo-taxi. And there's some similarities and there's some differences. If you think about users today, everyone has a smart device, and that device is, in many cases, people's world. They operate around it in their home or in their office, on the street. And when they come into the car, they expect it to connect seamlessly. They want some level of access to the same capability on that device that they have when they're outside the car. Obviously, in a driving scenario, there's distracted driving that comes into play, a lot of different elements there. But things like Apple CarPlay, things like the Android Auto, all of those things come together to allow some level of connectivity for the drivers. For the rear seat, different story. And that's where you start seeing all the multimedia come in. You've got the apps, you've got games, you've got interactive games even. So it's not just the watching a movie from the past, but it's now, okay, if I've got, if I'm leveraging or watching a movie on my TV, can I transfer that into my car? Those are the types of things and the type of experiences that we're seeing in the future. But for ride hailing, it goes beyond that. I mean, when you think about eliminating a human, every activity that human performed has to be replaced in some way. And that's where this connectivity experience can come in. That's where you can have some kind of payment process that's automated, connected to the cloud. You can have cabin monitoring that makes sure that everyone that's inside that vehicle is safe, but also if they leave something behind, that you can flag it and identify that person and make sure that they know about it. So it's really interesting because now we can kind of take the blinders off and we can imagine a world, and now we have the opportunity to create it.
Well, some of the connectedness stuff could be as simple as getting real-time traffic data,
Absolutely.
Right? So that your navigation system in the vehicle might be able to make a different decision for you to get more quickly to where you're going because, say, the road ahead has had an accident and is all clogged up.
Well, even one of the things they're talking about, because we all have navigation on our phones or maybe even nav in the car, is better navigation that says, okay, look, there's no way around the traffic accident, but get in the left-hand lane or the right or whatever it happens to be. But what I want to talk about or ask you about, Jada, is connectivity, cars talking to themselves so that we can have it so they never crash into each other. I thought in the U.S. we were moving right down that pathway.
V2V, John?
V2V, right. Vehicle-to-vehicle communication, or even vehicle-to-infrastructure or whatever. Where does that stand right now? Is Aptiv playing a role in that?
Well, it's interesting. We were the first to market with a V2V system leveraging DSRC, so that's dedicated short-range communication in Cadillac a few years ago. And we have a commercial service that's running our level 4 automated mobility on demand vehicles that are in partnership with the Lyft network. So it's leveraging our tech, Aptiv's tech, with Lyft's ride-hailing platform in the streets of Las Vegas. So we're giving rides to consumers with the Lyft app, which has been a fantastic learning experience for us. But one of the things that we did is we outfitted not only our vehicles with vehicle-to-vehicle communication, but also the infrastructure, because it's important that the vehicles, our cars, know where each other is, but at the same time that they're able to talk with traffic lights so that even if they don't have line of sight, they still are able to make the right decisions based on the data that's coming from that. So it's something that we take very seriously. We're very proud of our innovations in that space, and we're continuing to leverage that technology as we advance our automated mobility on demand fleet.
So these are Lyft cars in Las Vegas?
They are Aptiv vehicles that are running on the Lyft network.
Okay, gotcha. And as you know, you mentioned DSRC. Others are arguing, no, we should go to 5G LTE. And that seems to have stalled the whole thing of widespread adoption. Is that right? And how do you think it's going to end up, DSRC or 5G?
Well, it's a tough call to make which way it's going to go. 5G is very interesting, and when we think about the transition from 3G to 4G, it really changed things up, and there were use cases or situations that we couldn't have anticipated suddenly became available. And I think that the same thing's going to be true when it comes to 5G in general. When we think about an automated vehicle, though, or any vehicle that is requiring real-time information to be able to make life or death decisions, latency is incredibly important. And we need to make sure that we have the right pipes that deliver that latency, information.
Just to explain for you mean lag time.
Lag time.
Reaction time.
Reaction time. So if we need something, some piece of information that's either coming from the infrastructure, let's say, or from another vehicle, it's important, or the cloud, it's important that we have that absolutely as quickly as we possibly can get it. If there is too much latency, too much lag time in the receiving of that data, or even our transmission of data, that can present a problem.
And we're talking literally seconds here.
Literally,
well, because we can have two vehicles approaching an intersection at the same time. They're going to turn in the same direction, and you need to know the position of the other vehicle so that the vehicle can either stop itself, and then, in other words, would the vehicle that's might have the accident, would that vehicle then stop itself versus maybe turning into traffic or turning into the other vehicle?
It's tough to say in that particular example that you're bringing up. It's hard for me to follow a little bit, to be honest.
Okay.
But when we think in general, if we think generally speaking about the capability, the vehicle needs to get information real time, just like we operate. When we're driving a car, we have 5 senses, and we take information in through those 5 senses, and we combine all of it together real time, and we make decisions, and it happens lightning fast. Cars have to be able to do the same thing. We have all these different types of sensors on the car that operate as the senses. It's the eyes, it's the ears, it's the smell, it's everything, just like a human has. We have to take that data in, send it to the brains of the vehicle, the supercomputers that are powering it, and make those decisions. Sometimes that data comes off the car. It's not inside our sensors, it's elsewhere. We have to get all of that to the brain so we can make those decisions as quickly as possible. Can 5G do that? There's a lot of promise in that technology. So at the same time, we need to make sure that our cars today are operating with the highest level of performance, and that's leveraging DSRC technology. At the same time, if that means in the future that it needs to be 5G, we're more than happy to support that. We go back to performance. We need to make sure that we have the data that we need when we need it. And the best way to do that is what we'll use.
Is there still a squabble going on, John, on bandwidth?
I think that's been settled because there was a big argument for DSRC. Could they get an allotment for the bandwidth, like Jack's talking about, because others who want bandwidth, internet providers, telephone companies, wanted to get their hands on that. Yeah, well, how did that end up?
I'm not sure on that particular element. I'd have to follow up with you guys on that one.
Because the argument is, well, if you're not using it, we'd like to use it. Right. And they're like, well, we intend to use it, so
we need it there when
we need it to be there when we need it.
But to me, it seems that V2V could be the biggest safety breakthrough, maybe since the seatbelt. Because if you have cars communicating with each other and make it almost impossible for them to crash into each other, wow, what a step forward.
Right.
So to me, the argument has been, do you want a faster download of a movie or do you want to save lives? I mean, that's been my viewpoint on it.
It's incredibly powerful technology. And even for little things like seemingly little things, how many of us have been pulled up to a street light and there's a big truck or something in front of us, and we don't have line of sight to what that light is. We don't know if it's green. We don't know if it's red. Or it's a massive truck. We can't see who's in front of the truck. Is it the first one? Is it the third? And so we're kind of guessing. Okay, do I go? Do I wait? Do I go? Do I wait? Okay, I'm going to go, right? With DSRC, our V2I enabled by DSRC, we don't have to worry about that. Our vehicles can talk to the traffic light. Not only do they know what the state of the light is, but they know how long it's going to be in that state. And so there's no more guesswork. It's able to operate not only accurately with all the information it has, but efficiently too. So you're not guessing, how long has that light been yellow? okay, I can't make it, I gotta stop. Or, no, it's been red for a long time, I don't even need to slow down because it's gonna be green. We're guessing. The cars don't need to because they can talk directly to the lights. That's the power that this technology has.
So would the vehicle maybe be doing something different than what the driver's instructing? If to say that it's a yellow light and he's or she's got their foot on the gas to go through the intersection, the car's gonna stop versus accelerate through the intersection because the light's changing.
In the case of our automated vehicles, there's no in-between. Either the vehicle is operating or the driver is in control. There's not a situation where both can be in control at the same time.
So I'm assuming the vehicle takes over control. I mean, if it's a dangerous situation where the driver's trying to give it an instruction that might be dangerous.
That's where things like perhaps automatic emergency braking can come in, right? There's a very fuzzy line when you start talking about, are we talking an autonomous level 4 or level 5 system? Is this more of a level 3 highway pilot? Perhaps an advanced level 2 with highway assist? And what's that trade-off? Typically, anytime that you're talking about a vehicle, you really only want one master at any given time, and you want very clear rules as to who is in control at any given time. And that is why even in the case of AEB with forward collision warning, the forward collision warning is an opportunity for the driver to take over, saying, hey, this is something imminent, you need to react. And then automatic emergency braking steps in the event that the driver doesn't take that action. So it's very, in some cases, nuanced, in other ways not, but it's incredibly complex. And the great thing about not only technology providers like Aptiv, but our OEM customers, is that when we're able to make something look relatively easy, we've done a very good job.
To the point you made before, there's only one master. There's the human driver or the vehicle is taking over. Every study we do, and we've shown some backward movement, people are reluctant to give up that control. They're just not quite trusting, and some incidents that have actually happened have caused them to go back. How do we build the trust of humans, having trust in the automated technology?
Well, when we think about active safety, and then we'll jump to the automated systems here in a moment, but with active safety, people trust them because they've used them. And the more they experience exposure. When one of those active safety features saves someone's life and they talk about it, you instantly get believers and you get people who are evangelizing the technology.
Salesmen.
and it's similar to some degree with automated technology. So leveraging our partnership with Lyft in Las Vegas, we are doing surveys of people as they come out of our cars and say, hey, you know, what feedback do you have? What did you like? What did you not like? And we've learned a lot through that. And what we found is, and even in rides when I take with, you know, journalists like yourself or perhaps investors or customers, my favorite thing to do is to take someone who's never been in that car before, the very first ride in an autonomous vehicle. Because when they first get in, there's so much excitement and a little bit perhaps fear of what is it going to be like. And then they get in the car and they're asking all kinds of questions like, how did the turn signal come on? And how did the wheel move? And, oh, we just sped up, we just slowed down. How did you know to turn? So we answer all those questions, and then, you know, between 5 and 10 minutes into the ride, everyone's on their phone and they're checking their email or they're texting somebody, and that is the sign of acceptance, because now when it becomes boring, we've won. We've succeeded.
Boring is good. Yeah.
Boring when you're driving is very, very good. And we take great, great pride in that. And so the combination of the learnings that we're getting from our Lyft partnership and from the consumers that are actually in our Aptiv vehicles, and taking that back, feeding that back into our active safety systems, we're seeing that just like in the active safety space, over time, you're going to get more and more acceptance in the automated space as well.
You mentioned that Cadillac has started installing this V2V technology.
We were first to launch with them, yes.
First ones in the world. It's really impressive. What's the feedback been? Have other automakers approached you on this too?
It's interesting. There's interest there, but obviously we don't want to speak for our customers. We are very happy that the technology
I don't need you to name
was
them,
well received.
But you're saying there are other automakers coming and saying, we want it too?
People across the board recognize the power that is in vehicle to vehicle. and vehicle to infrastructure. And so now it's a matter of, does it make sense to put it in? What does the infrastructure look like? There's just like with automated driving, when we think about the technology there, a lot of times people are so focused just on the car themselves, but they don't stop to think about the impact that has on the environment around it. And that's one of the things when I talk about how we look at things holistically, we are focused on the whole system, and that includes the environment outside the vehicle as well. So when it comes to things like vehicle to vehicle, and by extension vehicle to infrastructure and all of that, it's taking a look at not only the vehicles, but saying, how can I connect in? How does this impact the infrastructure around it? What does the future look like? You mentioned the DSRC versus 5G discussion that's been happening, and I think that that's it's definitely relevant. It's something that is top of mind for many folks. And so I don't think that there's anybody that doesn't believe in the power of the technology. It's around the timetable, and it's around what's the plumbing? Is that plumbing DSRC? Is that plumbing 5G?
I guess we're interested in information regarding, a drop in statistics. John cited, 40,000 lives a year lost in auto accidents or auto-related accidents. Is there any sense that ADAS, the driver assist systems, or V2V, that we're actually starting to see, some numbers come down? Do you have incidents where you can cite, hey, this would have been an incident, it wasn't an incident? It's almost like the accident that didn't really happen at all.
And we need a quick answer.
We need a quick answer. Well, here's what I can tell you, that studies have shown that if we can shave a half a second off of reaction time, we can prevent 60% of accidents. And active safety technology delivers that.
Really good. With that, we're going to have to wrap it up. Jada Smith, thanks so much for coming in.
Thank you.
Very interesting discussion.
Thank you very much.
Jack Keebler, Michelle Krebs, thank you guys too.
Thanks, John.
And as I always say, I want to thank all of you for having tuned in.
Underwriting for the production of Autoline This Week has been provided by Borg Warner.
The world is changing at an ever-increasing pace. No matter what the mode of transportation, there is always the need for an efficient propulsion system. And that's exactly what Borg Warner has been doing since the earliest days of the automotive industry. We create innovative mobility technologies that reduce energy consumption and emissions while improving performance. Our proven track record has made us an industry leader in forward-looking propulsion solutions for combustion, hybrid, and electric vehicles.